Good morning, everyone. So, in the last class, we have discussed the complex analysis. That is nothing but complex numbers. So, how do we define complex number? So, complex number can be represented in the form of, if the number can be represented in the form of z is equal to x plus iy. Here x is called the real part and y is called the imaginary part, and the value of this iota or I is nothing but a square root of minus 1. In general, actually, we consider the value of imaginary number is square root of minus 1 here, and we discussed so how we can apply the complex numbers in the field of algebra, geometry, calculus, and all. And in general, I mean, so directly how we are going to apply in the field of calculus. Actually, calculus is nothing but so in general, actually, calculus can be defined as it is nothing but a systematic way of finding the solution or of solving the equations. That is the general definition actually for calculus. But in mathematics, especially in class +2, I mean in PU and all, so they used to say calculus is nothing but it is nothing but a combination of it constitutes integration as well as differentiation. So like that we defined according to our way. But in general, calculus can be defined as what? It is nothing but a systematic way actually. Systematic way of finding the solution for a given equations. Is it clear? So now, with respect to the complex analysis or the general definition of the differentiability is for real function, I'm telling, not for complex number. Is clear? Real function means y is equal to f of x. Here we are having only a single independent variable. With respect to this, I am just writing the definition of differentiability, that is dy by dx is equal to limit x tends to 0, okay, delta x actually, f of x plus delta x minus f of x divided by delta x. So actually this is the general definition or mathematical definition for the differentiability. If the derivative exists, is it clear? If the derivative exists for a given function, then it is said to be analytic function. If the derivative exists, that is nothing but if y is a function, right? If y is a function of x, derivative should exist means so derivative of this function is dy by dx. If this exists, then the function is said to be analytic. Is it clear? You should know the definition of analytic function. So what is analytic function means? Derivative should exist, or else dy by dx. Derivative is nothing but dy by dx must exist. Then the function is said to be analytic. With respect to this is single valued function, but here we are discussing the complex valued function, right? Complex valued function means like this we are discussing. W is equal to f of z. W is also a complex number and z is also a complex number. What is z now? Z is equal to usually x plus iy we take. X plus iy. Is it clear? So it can be done as what? U of x comma y plus I into v of x comma y. See here, w is a function of u and v, and z is a function of x and y. So like that, this is also a complex number, and the domain and the image is also a complex number here. So like this, with respect to two independent variables, the definition of differentiability will change here. This is with respect to single valued function, I said. So for for a complex valued function, we define like this actually. This one dw by w is a function of z, dw by dz or f dash of z in general. F dash of z is equal to limit delta z tends to 0. Limit delta z tends to 0. See here. Just try to understand this because next I am going to prove the theorem. So there I need this statement. F of z plus delta z minus f of z divided by delta z. Is it clear? F of z plus delta z minus f of z divided by delta z. Then we used to take f of x plus delta x minus f of x divided by delta x. But what is z now? You should know these things now. Z is equal to x plus I, right? Then z plus delta z or delta z. What is delta z now? Z plus delta z means it is nothing but the increment in the value of z now. So delta z will become delta x plus I into delta y. limit delta z tends to 0. So if it is tending to 0, we are having two possible cases. Either this must be equal to 0 or this must be equal to 0, right? But both cannot be 0 at a time. That you should understand. Both cannot be 0 at a time. So for the reason, either this must be 0 or this must be 0 here. Is it clear? So just remember the definition of differentiability. So other things I'll just make it to understand now. So next, with respect to this, I'm going to prove one important result, that is CR equation or the Cauchy-Riemann equation in Cartesian form here. This is 200%. They will ask out of two theorems, they will ask one in the examination for 7 marks here. Do remember I'm telling now also. Like this only they will ask Cauchy-Riemann equation in Cartesian form actually. So in Cartesian form actually, this is a very important theorem. They ask in the examination like this: state and prove. State and prove Cauchy-Riemann equation in Cartesian form. Another one case is there, that is polar form. See, it is also called as CR equation. CR, Cauchy-Riemann equation in the Cartesian form. So let us prove this. First, the statement is the necessary conditions. The necessary conditions. The necessary conditions that the function. The necessary conditions that the function. That the necessary condition. W is equal to f of z. W is equal to f of z, where that W is equal to f of z is a complex number, right? This f of z I'm going to define like this. Here f of z is equal to, where f of z is equal to u of x comma y plus I into v of x comma y. Like this I'm defining f of z. Clear? F of z is equal to u of x comma y plus I into v of x comma y. Maybe analytic. Analytic at a point. Maybe analytic at a point z is equal to x plus I by, means the given function is analytic at this point z. Then there exists first order 4 continuous partial derivatives. First order 4 continuous partial derivatives. See, derivation is very easy now. Certainly, statement is little bit lengthy. That's all. Then there exists first order 4 continuous partial derivatives. See here, u is a function of x and y, and v is a function of x and y. Right? 4 continuous first order partial derivatives means I am differentiating with respect to x now. Is it clear? Partially. So this term will become dou u by dou x. Similarly, dou u by dou y. Okay. Next, v is a function of x and y. Dou v by dou x and dou v by dou y. So first order 4 continuous partial derivatives are generated now, such that which satisfies the equation dou u by dou x is equal to dou v by dou y. Is it clear? Dou u by dou x is equal to dou v by dou y, and dou v by dou x is equal to minus dou u by dou y. If it satisfies this condition, these two conditions, then the equation is said to be analytic also here. Is it clear? Mathematical definition of analytic is what? Derivatives which exist, and also alternate definition is while solving problems and all. If it satisfies these two conditions, if they are equal with respect to these two conditions, then also the function is said to be analytic. Clear? So now I am going to prove this result. See, just try to understand. This is the statement, right? From the hypothesis. So from the hypothesis, what they have given? Here, the necessary condition, let it be The function w is equal to f of z. F of z is defined in the form of u of x comma y plus I into v of x comma y may be analytic. Maybe analytic means derivative should exist. So for that reason, I'll just clear this. See, with respect to this, maybe analytic they have given, right? Analytic function from the hypothesis it is given as analytic. So analytic function means derivative should exist. I'm going to write the definition now. With respect to statement, I'm writing here. Since the function is analytic, since the function is analytic from the hypothesis, then f dash of z. I'm not going to write the derivative. Derivative of z. Derivative is nothing but f dash of z. So f dash of z is equal to limit delta z tends to 0, f of z plus delta z minus f of z divided by delta z exists. Right? Derivative exists since the function is analytic. So now, what is z and what is delta z now? Already I said that z plus delta z is nothing but the increment. Is it clear? Increment in the value of z actually. Minus means decrement. Actually, here we are having z plus delta z, so it is considered as the increment in the value of z now. Similarly, what is z now? Z is nothing but we know that x plus I by right. So this implies z is x plus I by. Delta z is delta x plus I into delta y. Means delta x and delta y are nothing but the increments in x and y respectively. See, x and y. So then what is this term will become? F of z means I'm going to substitute this u of x comma y plus I into v of x comma y. Then what is f of z plus delta z now? Can you tell me? F of z plus delta z. So now see here, f of z, in place of f of z, I'm going to substitute, it is given already in the statement, u of x comma y plus I into v of x comma y, right? Next, I'm asking, in this place, what you can write, I'm asking.
So z place only x plus iy plus
Z plus delta z, together I'm taking here. Z plus delta z. F dash of z here. Here, f dash of z is equal to limit delta z tends to 0. One step number there, the derivative should exist, and we define this convex number like this. F of z plus delta z. What is z actually? F of z is u of x comma y plus I into v of x comma y, right? Z ಜಾಗದಲ್ಲಿ ಏನಿದೆ? Z plus delta z ಇದೆ. Then what about x and y? So my point you are getting right. ಹಾಗಾದ್ರೆ ಏನು ಬರೀಬಹುದು ಹೇಳಿ ನಾನು?
u of z comma delta z.
Z ಜಾಗದಲ್ಲಿ ಏನಿದೆ? Z plus delta z ಇದೆಯಾ? But what is z before that? Z is x plus I by right? ಇಲ್ಲ.
Yes,
this entire term. If you consider this entire term, then now what is f of z?
u of x comma y
Plus I to v of x comma y. Z plus delta z ಅಂತ ಏನು ಹೇಳಿದೆ ನಾನು? It is nothing but the increment value, right? Then what about x comma y? X increment ಏನು, y increment ಏನು? ಇನ್ನೊಂದು ಅರ್ಥ ಆಯ್ತು ಮುಗಿತು. Next the thing is easily can understand. Yeah, in place of z, we are having z plus delta z, right? Z ಜಾಗದಲ್ಲಿ z plus delta z ಇದೆ. So for that reason, x will become x plus delta x, and similarly y will become y plus delta y. Increment ಆಗುತ್ತೆ. So this term will become what? U of x plus delta x comma y plus delta y plus I into v of again x plus delta x plus comma y plus delta y. So this part is finished. Next minus, I write here minus, use bracket. Okay, next minus f of z. What is f of z now? See here it is given u of x comma y, u of x comma y plus I into b of x comma y divided by delta z. What is delta z now? Delta z is nothing but delta x plus
I delta.
delta x plus I delta delta. Is it clear? So just call, or else one more step is what? So I'll just separate real part and imaginary part here first. So separating real part and imaginary part, that is equal to limit delta z tends to 0. It is not step early. This let it be delta z only. One more step later we can take it. Here limit delta z tends to 0 is equal to, here real part and imaginary part I am going to separate here. So real part is what? U of x plus delta x comma y plus delta y. This is I. Then imaginary part, and here minus u of x comma y is the real part. So u of x plus delta x comma y plus delta y real part minus u of x comma y. So this is your real part divided by delta z. Split ಮಾಡಬೇಡಿ, real part and imaginary part plus I into next imaginary part I common term ತಗೊಂಡಿದ್ದೀವಿ. Fine. So remainder is what? B of x plus delta x comma y plus delta y. So minus into plus is minus B of x comma y divided by delta z. So call this as equation to 1. So now, okay, I'm just calling this equation as number 1 now. We know that delta z is equal to delta x plus I into delta y. Is it clear? Delta z is nothing but delta x plus I into delta y. And the thing is, here limit delta z tends to 0. If this is tending to 0, if this limit is tending to 0 means either this must tending to 0 or this must tend to 0. So together I cannot take, simultaneously I cannot take. So for that reason, first then case 1, case 2 over. Clear? So we go for case 1 and case 2. See here case 1 limit this one delta z tends to 0 implies delta x tends to 0. Is it clear? Delta z tends to 0 means delta x tends to 0 totally, and this term will become delta y is equal to 0 here. Delta y is equal to 0. At least one term should become 0 right here. And what is delta z now? If delta y is equal to 0 here, what happens? What is delta z now?
I sir.
I. Delta y is equal to 0, right? Exactly, I am taking delta y is equal to 0. If this term will become 0, then what is delta z? I am asking this.
Delta x sir.
Delta x, okay, delta x. See, all these things are going to substitute in equation number 1. Is it clear? So, in the case 1, case 2 is very easy, I am telling you. Okay, first case delta y is equal to 0, second case delta x is equal to 0, and what is the equation now? Fine. So all these things are going to substitute in equation number 1 now. So equation number 1 we press f dash of z is equal to, yes, limit, here limit delta z tends to 0. Delta z tends to 0 means delta x tends to 0 here. So for that reason I take delta x tends to 0. Next, here u of x plus delta x आगे बढ़ो here. Delta y is equal to 0 actually. So here it will become 0. Delta y is equal to 0 means y plus 0 is y. Like this. Minus u of x comma y divided by delta z. What is delta z? Delta z is delta x. Only these things I have to substitute. That's all. Delta x plus I into next. Here v of x plus delta x comma y plus delta y. The value of delta y is 0. So remainder is what? v of x plus delta x comma y minus v of x comma y divided by delta z is nothing but delta x. So according to that equation, is it clear? So ist ಆದ್ಮೇಲೆ, so after this here, so just remember this because for case 2 also I made this. Okay. Okay, now we can check this. See what exactly you can write this. Limit delta x tends to 0. Is it clear? Limit delta x tends to 0. So it is in the form of what? See here, f of z plus delta z, f of z plus delta z minus f of z divided by delta z you can write. So what is this term you can write? ಈ term ಏನು ಬರೀಬಹುದು ನೀವು?
delta x
Actually, what is this called?
real parts.
D? ಹೇಳಿ ಸಾಗರ್. This is nothing but the differentiation definition, right? I said already. Differentiation definition it is. See here, f of z plus delta z minus f of z divided by delta z. So this is nothing but the definition of differentiability, I said. But particularly here we are writing x angle x plus delta x with respect to x, right? So first order partial derivative is, that is u with respect to x. Instead of writing df by dz, is it clear? Instead of writing df by dz, I am going to write it as partial derivative because they are having two independent variables, that is dou u by dou x plus I into, here also b with respect to x we are having. So I'll take it as dou v by dou x. So call it as equation number 2 now. Similarly, go for case 2. What is the case 2? See case 2. Case 1 alli tondidhi delta y is equal to 0 tondidhi, right? So I'll take delta x is equal to 0 now. Next delta z tends to 0 in place what now? Or should I write that one? You ಅರ್ಥ ಆಗಿಲ್ಲ ಇದರಲ್ಲಿ delta z tends to 0 ಇರುತ್ತಲ್ವಾ? Or delta z is equal to delta x plus y delta y. Already case 1 alli tondidhi, this is equal to 0 tondidhi.
Yes, sir.
Case 2 I'm going to take delta x is equal to
Delta x is equal to
0. Next, what is delta z tends to 0? Value of delta x is equal to 0. This term 0 out, okay. This term will become 0. Now, what should I write here?
I delta y.
Very good. Delta y tends to 0 when delta x is equal to 0 means delta z is equal to I into delta y, right? So again these things I'm going to substitute in equation number 1. I said there I'll substitute ಮಾಡ್ತೀನಿ. Where exactly? So here. So limit, okay, limit delta z tends to 0, that is the definition. Delta z tends to 0 means delta y tends to 0 here. Delta y tends to 0. Next, u of x plus delta x. Delta x is equal to 0 here. Delta x is equal to 0, so I am going to negate that one. Next, comma y plus delta y, because they are tending to 0, that I have to substitute later limit, minus u of x comma y divided by delta z. Delta z means I into delta y. It's not I into delta y. Next, plus I into v of term. I mean imaginary term. Same thing. V of x comma y plus delta y minus v of x comma y divided by delta z is nothing but delta I y. Okay, equation number 2 ನೆನಪಿರಲಿ. So now here again it is in the form of f of z plus delta z minus f of z divided by delta z. So it is in the form of u with respect to y. Actually, definition of differentiability. U with respect to y here, and this I also I will write as it is 1 by I into dou u by dou y. Next plus I will get cancelled here. So remaining term is what? V with respect to y here. Dou v by dou y, or else one more step 1 by I here. What is 1 by I? I will simplify this 1 by I. One complex number ಇದೆ 1 upon 2x minus I3y ಅಂತ ಒಂದು ಫಂಕ್ಷನ್ ಇದೆ. ಸೊ ಒಂದು ಕಾಂಪ್ಲೆಕ್ಸ್ ನಂಬರ್ ಇದೆ. ನಾವು ಏನು ಸಿಂಪ್ಲಿಫೈ ದಿಸ್ ರಾಷನಲೈಸೇಷನ್ ಮಾಡ್ತೀರಲ್ವಾ, rationalization. Similarly 1 by I ಗೆ rationalization ಮಾಡಿದ್ರೆ what exactly will get? Multiply and divide by minus I actually. Rationalization multiply and divide by minus I with respect to denominator. So 1 into minus I is minus I. Okay, I into minus I. The value of I square is minus 1. So minus into minus it becomes plus 1. So in place of 1 by I, I am going to write directly minus I here, right? Minus I by I. So minus I dou u by dou y plus dou v by dou y. So call it as equation number 3 now. Equation number 3. Here equating real parts and imaginary parts. Real part ಯಾವುದು ಇದೆ? Equation number 2 and 3 ಅಲ್ಲಿ
dou u by
real
dou
part.
x, dou u by dou x, dou u by minus I, dou u by dou y.
I ಬರೆಯಂಗಿಲ್ಲ, only real part ಅಂತ ಹೇಳಿ. Okay, dou u by dou x equation number 2 ಅಲ್ಲಿ and dou v by dou y and now only imaginary parts here. Imaginary parts in equation number 2 is you should not write I am telling.
Yes, sir. Dou
Okay,
v
I
by dou
ಬರಿಬೇಡಿ.
x,
First step dou v by dou x is equal to
dou u by dou y.
so you should not forget minus dou u by
Yes, dou u by dou.
dou y. Here the conditions are be opened. So dou u by dou x is equal to dou u by dou y and dou u by dou x is equal to minus dou u by dou y. This is the required result. That is the required CR equation in Cartesian form. Okay, so now also I'm just telling this is a very important proof for examination in all question papers. So ಎರಡು ತರ ಇದೆ. This is Cartesian form. Tomorrow or in the next class I am going to discuss plural form. Out of 2 definitely you will get 1 question for examination. Now also I'm telling you. ಮತ್ತೆ maths ಅಲ್ಲಿ fail ಆಗ್ಬಿಟ್ಟು don't suffer for such things. Anyway, I'm just sharing these notes in the teachment app so that start studying from now only. For examination I'm telling, not for internals and all. I'll pass ಆಗ್ಬೇಕು ನೀವು, not here. You are my students and ಸ್ವಲ್ಪ ಸಾಫ್ಟ್ ಕಾರ್ನರ್ ಇರುತ್ತೆ. I'm giving marks for them. So for that reason exam alangala your paper will be valued by the another evaluator. So for that reason there will be no sentiment for giving marks. ಈ derivation ಕೊಡ್ತಾರೆ ಅಂದ್ರೆ definitely they will give. Is it clear? ನಾನು ಹೇಳ್ತಾ ಇದ್ದೇನೆ ಎರಡು derivation ಇದೆ ಈ ಮಾಡ್ಯೂಲ್ ಅಲ್ಲಿ. So out of 2 derivations 1 derivation ಕೊಡ್ತಾನೆ. So 1 derivation means at least you must learn from now only. 7 marks in pocket ಅಲ್ಲಿ ಇದೆ ಈಗ. Okay, everyone are telling Jabbar, Sagar,
Yes.
ಎಲ್ಲರೂ ಓದ್ಕೊಳ್ಳಿ ಆಯ್ತಾ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಹೇಳ್ಬೇಕು. Okay, then tomorrow I'll continue the next part.
Thank you, sir.
Okay, yeah, thank you. Okay, 1 second. Okay, fine. So actually statement in the statement only they have given that necessary conditions. Necessary conditions that the function w is equal to f of z. See, they have given the necessary conditions that the function w is equal to f of z, where that f of z is defined like this, complex value function. f of z is equal to u of x comma y plus I into v of x comma y. Maybe analytic. Maybe analytic. See, from the definition of analytic function, already I said still the statement is there, but the thing is, you try to analyze like this only. It will be easy for you to proceed for the proof. See, it may be analytic at the point z is equal to x plus I by. Then what is analytic function actually? So analytic function, the given function is this: f of z is equal to u of x comma y plus I into v of x comma y. Maybe analytic. Analytic function means what is analytic function? Derivative must exist, right? Derivative must exist with respect to the complex valued function, or else f dash of z exists and it is said to be unique here. So f of dash of z is equal to what? Delta z tends to 0. F of z plus delta z minus f of z divided by delta z exists and is unique. Exists and is unique. Is it clear? So this is the definition of the differentiability function. Right. Next. And in the statement itself, they have given that. So maybe analytic at the point z is equal to x plus I by. Then there exists. The first order 4 continuous partial derivatives with respect to the complex function. See, u is a function of x y, right? So derivative obviously dou u by dou x, dou u by dou y. Next v with respect to x and y. So partial derivatives, first order dou v by dou x and dou v by dou y such that which satisfies the equation if it satisfies this condition. Dou u by dou x is equal to dou v by dou y and dou v by dou x is equal to minus dou u by dou y. If it satisfies this condition, then also the function is said to be analytic, and this is nothing but the CR equation or the Cauchy-Riemann equation in Cartesian form. In the Cartesian form, if it satisfies these conditions, then it is said to be the analytic function. Is it clear? So now, what is the next point? So derivative exists, and the function also they have given here, and the function is given in the form of f of z is equal to u of x comma y plus I into v of x comma y, right? So let us take that.